Welcome to lesson 4.9, which is the last lesson in unit 4. And this lesson is going to be about switching between the vertex form and the standard form of the quadratic relation. So here's a good example that you can go through on your own. But we're going to get started. We're going to start by looking at converting from vertex form to standard form. So recall the vertex form of a quadratic relation is in this form right here. Y equals a times x minus h squared plus k. And that's where h and k are the coordinates of our vertex. So a lot of times we like to have our quadratic relation in vertex form just so it's easy to see where our vertex is. So to switch from vertex form to standard form, we're just going to follow these steps. Step 1, we're going to expand the vertex form using the distributive law. And then step 2, we're going to simplify it by collecting our like terms. And once we've done that, we're actually in standard form. Now, if we need to change the relation to factored form, we'll just follow the steps for switching from standard form to factored form in the previous lesson. A lot of times, if a quadratic relation is in vertex form, when you go to standard form and then try and go to factored form, a lot of times you need to use the quadratic formula to find your factors. So we're just going to focus on flipping between vertex to standard form and standard to vertex form. So, example, rewrite the following quadratic relation from vertex form to standard form. And so here we have our quadratic relation, y equals 2 times x minus 2 squared minus 3. So we're going to expand this. And x minus 2 squared can also be rewritten as x minus 2 times x minus 2. So our new quadratic relation is y equals 2 times x minus 2 times x minus 2 minus 3. Now we're just going to use our distributive law. We could distribute the 2 between our first x minus 2, but I'm going to use the other method where we're going to distribute our two binomials first, and then we'll distribute the 2 throughout. So I'm going to use FOIL, and if you remember FOIL, first, outside, inside, last, it tells us the order to multiply our binomials. So we're going to start with our first, x times x is going to be x squared. X times minus 2 is minus 2x. Minus 2 times x is minus 2x. And minus 2 times minus 2 will become positive 4. And then we still have our minus 3 outside the brackets. So now we're going to just collect our like terms inside the bracket. So we'll have 2 times x minus x squared minus 4x plus 4 minus 3. At this point, we can distribute the 2 through the 3 terms that are in our brackets. So we'll do that, and 2 times x squared is 2x squared. 2 times negative 4x is negative 8x. 2 times 4 is 8. And we still have minus 3. So now we're once again going to collect our like terms. So we'll do 8 minus 3 there. And we'll get our final form here, the standard form. Y equals 2x squared minus 8x plus 5. So the quadratic relation is now in standard form. If we wanted to change the standard form to factored form, we could, but we would need to use the quadratic formula to find the factors. So our first step would be we would have to factor 2 out of all these terms because we don't want to have a coefficient in front of x squared. So we do that and then try and factor what's inside the brackets, and we would need our quadratic formula in order to figure out what our factors are. We're not going to do that though. All right, let's do one more example here. So we want to rewrite the following quadratic relation in standard form. And we have y equals minus 3 times x minus 5 squared minus 2. So I encourage you at this point to pause the video, try this one on your own, and then restart the video to see if you got it right. Okay, so let's start it off. We're going to expand this. So x minus 5 squared is the same as x minus 5 times x minus 5. So y equals minus 3 times x minus 5 times x minus 5 minus 2. So we'll go through the same process we did before. We use FOIL. X times x is x squared. X times minus 5 is minus 5x. Minus 5 times x is minus 5x. So when we add those together, we get minus 10x. And minus 5 times minus 5 is 25. And then, of course, minus 2. So now we're going to distribute the negative 3 throughout our trinomial in the brackets. We'll get negative 3x squared plus 30x minus 75 minus 2. Last step here is just collect our constants. So our final quadratic relation in standard form is going to be y equals minus 3x squared plus 30x minus 70. All right. So going from vertex form to standard form isn't too bad, just expanding and simplifying using the distributive law. When we want to go from standard form to our vertex form, we have to use the completing the square method. So switching from standard form to vertex form, and to switch from standard form to vertex form, as I said, we needed to complete the square. So we're going to look at an example here. We already know the steps in completing a square. So rewrite the following quadratic relation in vertex form. Y equals x squared plus 6x minus 8. So just like before, I want to get my constant to the other side. The one difference here before from our previous lesson on completing the square is in those cases, we normally set our equation equal to 0. Here it's set equal to y. We can't get rid of y. We're just going to keep it there. It's not going to do anything. So we're going to bring the 8 and minus 8 to the side with the y. So we'll have y plus 8 equals x squared plus 6. So now what we want to do is we want to complete the square. So in order to complete this square, we need to find our last term. Since we're dealing with a simple trinomial here, so we don't have a coefficient in front of x squared, we can simply take our second, that should have an x on it, I just realized. We can take our second term of 6x and simply divide it by 2 and then square that number, and that'll be our missing constant here. So 6 divided by 2 is going to give us 3. That's b, but we need b squared, so 3 squared equals 9. And now we add 9 to both sides of our equation, because what you do to one side, you must do to the other side to keep the integrity of the equation. So now we have y plus 8 plus 9 on the left-hand side equal to x squared plus 6x. Don't know what happened to my x's. Plus 9. So x squared plus 6x plus 9, that's now a perfect square trinomial. And that is x plus 3 squared. Remember, if you are ever concerned as to what your second number here is inside the brackets, this is b. And we found b by taking our middle term dividing by 2. So b was 3. So we get x plus 3 squared. And if we expanded that, we would get x times x is x squared. 3x plus 3x is going to be 6x, and 3 times 3 is 9. So it all works out there. So we're almost done at this point. We're almost in vertex form. We just need to bring the 17 back over to the right hand side of the equation. So we'll get y equals x plus 3 squared minus 17. Now we know our vertex is at minus 3 minus 17, and we're in vertex form. All right, one last example, and this time we're going to use x squared minus 18x plus 2 equals y. So, once again, we want to get our constants to the other side. So we're going to get x squared minus 18x equals y minus 2. Don't worry about the y. We're not going to do anything with it. It'll just stay on that side of the equation. Everything else will work out. So now we've got x squared minus 18x. We need to find our missing third term that would make that a perfect trinomial square. And that is going to be, we're going to divide minus 18 by 2. We'll get 9. And or we'll get minus 9, sorry. And minus 9 squared is going to be 81. So, just like we did before, we're going to add 81 to both sides of our equation to keep the integrity of our equation here. So now we get x squared minus 18x plus 81, which is a perfect trinomial square, equal to y minus 2 plus 81. Remember, when we divided our middle term by 2, we got minus 9. That is the number that we had to square to get 81. So that is going to be in our equation here. X minus 9 is now squared. And that's equal to y. I just combined our terms here, plus 79. Last step to get it into vertex form. Let's bring that 79 to the other side. And we now get x minus 9 squared minus 79 equals y. And now we're in vertex form, and we can once again see our vertex is at positive 9, negative 79. I hope you enjoyed that, and now that you've gone through these videos, you're ready for the end of unit assignment. So good luck with that, and if you have any questions, please let me know. Take care.